afternoon, everyone. Myself Sakshi Mittal. I welcome you all to this lecture on 8086 programming. And I'm an assistant professor in Department of Electronics and Communication Engineering at AKGEC Engineering College, Rajasthan. So this lecture I'm basically recording for the subject KCS 403 Microprocessor. So we'll discuss about the basic programming concepts used for 8086. So I'll take 4 examples, and with the help of 4 examples, we'll try to understand the instructions, how we can use the instructions in 8086 processor. As 8086 and 8085, they are a bit different. Like 8085 used to follow the linear addressing, but 8086 used to have a segmented addressing. So if you have segmented addressing, that means you have different segments to store your program and data. So to write your program, you can just initialize the input or your data part in the data segment, and you can start writing a program in the code segment. So the writing style, how you write the program in 85, it varies how you write the program in 8086 with the help of assembler directives. So I'll first take the example for BCD to hexadecimal conversion. That means I have a BCD number and I want to convert it to a hexadecimal number. So how can I convert it to a hexadecimal number? How can I convert it? If I have a BCD number, that means I have to check, like if I have a BCD number, I can first convert it to a binary number just to verify whether the output is correct or not. And same with the hexadecimal number which you are getting at the end, you can just convert it back into the binary number. If both the numbers match, that means you have got the correct output in the form of a hexadecimal number. So we'll start this first thing is where I am writing my program, from which location I am starting my program. So there are two things. First is your source location, another is your destination location. So I am assuming here that my source, my input is being stored at one location. Let's say it's starting from 500, and the destination, it can be at location 600. So first you have to start writing a program. So the program, we are just starting here from the location 0400. So 400 is the location we are being starting here. Now first instruction says move SI, 500. As we all know that move SI, 500, it is a case of immediate addressing. So in this case, this 500, it is a number which will move to register SI. So SI will be having 500. So it is actually my source location. It is my source location where my input is being present. And this is the offset address for the source number. So this is the offset number. Next is the move DI, 600. So now I am saying where I have to store my output, the output which I am getting in the hexadecimal form, where I need to store that output. So again, we are saying that move DI, 600. So 600 will be the offset of my destination, which I am storing in register DI. So SI is now pointing, SI is having 500 in it and DI is having 600 in it. So these both are the examples of your immediate addressing. So both the immediate numbers are being stored in your SI and DI registers. Next is move DL, square brackets SI. Now we says that you have to move the contents. Now what is the square brackets indicate? These square brackets indicate the content in register, the content in SI, it is the offset address, and you need to transfer the contents from this offset address to BL. So SI is pointing at 500. So 500 is the address where my source is present. So from that particular source, your that is 500 location. If for example, I have a number here as 42. So register BL will be having number as 42. Then I said that and now you've got the input. So it says that and the contents of register BL with 0. That means I want to mask the digits. Why I want to mask the digits? When we talk about the BCD number, then you have 2 BCD digits. So you must unpack those digits. So I am saying here that first mask the bits, first mask the upper bit. So we are saying that and the contents of BL with this the contents of your with 0F. So if I perform this like 42, if I mask it with 0F, if I perform the AND operation, if 0 is ANDed with this, I'll get 0, 2. So when I perform the AND operation on the contents of BL with 0F, then the contents in BL. So BL will be having 0, 2 in it. Then I said move again in AL the contents of SI. Again your SI is pointing at the location 500. So at 500 offset, you are having a number 42, which I assumed here is my input. I have to move again the content to AL. So again the same input is being moved to the accumulator. And now I perform again I want to perform the masking and AL comma F0. So this time I want to mask the lower bits. So when I perform this masking, 42 is ANDed with F0, so we'll get as 40. So in accumulator, I'll get it as 40. Since I am interested in getting both the digits, I want to get a 4 and 2 separate. I want to unpack the BCD numbers. So that means I'm not interested in 40. Rather, I'm interested in 04. So that means I must swap the 4 bits. So it says that you want to shift your data by 4 bits because I'm having 40. So 4 is in the upper bits and 0 is in the lower bits. So what I want to do, I want to just swap both upper and lower nibble. So move CL comma 04. In 86, register CL is a default counter. So we have put a count value 04 in register CL. Then ROR, rotate right. So you have to rotate right. Which contents you have to rotate right? So you have to rotate right the contents of AL and CL times. So I'm having the data in accumulator, that is 40, and I have to rotate it 4 times. When I'll rotate it right 4 times, this data will become 04. Now, so we have unpacked the numbers. I have got in register BL 02 and in register AL I'm having 04. So the concept which we are using here for conversion is like we used to have in the expanded form. If I have got a 42 number, so how can I write it? I can write this 42 as 4 into 0A plus 2. So the same concept I'm using here. So I have to multiply it with 0A. That means 0A is the immediate number which I want in one of the register. So move DL comma 0A. So 0 is the immediate number which will move to register DL. Then multiply DL. So this DL, this multiply instruction says that the contents of DL, they will be multiplied with the contents in AL. So AL is having in it 04. 04 will be multiplied with 0A. You have got the answer in AX, a 16-bit answer in AX. If it is 8-bit answer, then you will get the lower 8-bit in lower accumulator and the upper 8-bit of accumulator will be 00. Now what I need to do? So I have performed this multiplication, then I should add the lower byte. Then add the contents of accumulator. If you are, whatever you are having in the AL, the lower byte of your result, add it with the contents in BL, that is 02. So when you will add the result, you will get again your answer in your AL. Just move your answer to the address pointed by DI. DI is having the offset of your destination location. So just transfer that data to that particular location, that is 600. And last is the identify. You can have a software interrupt because in this program, I have not just entered the data. So if we have entered the data in the program, then I can write halt to terminate the program. And one more thing you can see here, that the addresses, I have started writing my program at location 0400 and this is the offset address. If I say that I've started writing my program from, let's say, 1000 segment address or maybe 00. So the segment address is 00 for all the locations and only the offset address is changing. So this will be same for all the locations and you are changing just the offset address. So in this program, what we have done, we have got a input, a BCD input in one of the location. And I'm saying that my source is having the offset of 500. So how will you convert the address? Whenever you are having this instruction where you have got the square brackets, you need to generate a physical address. Obviously, processor will generate a physical address on its own. So how will it generate the physical address? So the contents of segment, the contents of data segment, they will be multiplied by 10. And the contents of offset will be added. So if I have written like a move DL comma SI, so what this instruction will actually perform, how they will generate the address. The contents of data segment will be multiplied by 10 and the contents of SI will be added to it to get a 20-bit physical address. So in this way, you will get a 20-bit address. This is the location from which you are supposed to move the contents to register BL. Same way, when you are having this instruction, move square brackets DI comma AL. This instruction again says that you need to generate a 20-bit physical address. So addresses which we are mentioning here, which we are incrementing or which are incrementing on its own, they are just the offset address. So what we have done in this program, like we have assumed here the input is 64. So first I have got the input as 64. Then we have separated the digits. We have unpacked the numbers into 06 and 04. So how can I unpack the numbers? So first you have to perform masking. So by performing the AND operation with 0F, we have got 04. By again, the same input is being loaded, 64. We have performed the AND operation with F0. So this time we have got 60. Now you are interested in 06. So how can I get it 06? Just rotate it 4 times. Now see this part. I have to rotate it 4 times. So we have just rotated. Just see, every bit is shifted 1 position. So this is shifted here. In next rotation, this one will come here and this here. So this 60 becomes 06 in 4 rotations. So now you have got the numbers. Now the concept we are using is in this number will be multiplied by 0A plus 4. So if you multiply your 6 with 0A, then you will get 3C plus 4. You get 3C plus 4. So it gives you 40. Because 3C, then it becomes 3D, 3E, 3F, then 40. So it becomes 40. Now see, if I convert this number into BCH form, that is binary coded hexadecimal. So 0 will be represented in 4 bits, 4 zeros, and 4 will be represented as 0, 1, 0, 0. Now just try to convert into the binary form. So it will be 2 to the power 0, 2 to the power 1, 2 to the power 2, and so on. So this place, it becomes 2 to the power 6, that is 64. So this was the input. I am getting the output as 14 hexadecimal. That means the 40 is the equivalent hexadecimal number for my BCD input 64. So we have just verified it with the help of a binary format. I have converted into BCH format. From BCH, I have checked that if this is the BCD format, what will be the what will be my input. So we have got that if it is 2 to the power 6, it becomes 64. So we have verified in this manner. Next is if I have to do the vice versa. If I have got a hexadecimal input and I have to convert it to a BCD number. So we have to just repeat, we have to just reverse the complete process. So I say that I have got an input. For example, I've got an input FF. It is my hexadecimal input. So I say that the hexadecimal input I have to convert it to BCD. What output actually I am expecting it should come out of here. FF means 255. So output I want is 5, 5 and 2. That means I want to display the 3 digits separate at 3 different places. How can I achieve this? So first is that I will first perform the division with 100. I will first divide it with your maybe 64H. Then you will get the quotient part and a remainder part. So quotient is the one of the digit that you will just display, and the remainder again you need to divide it by 10. So you will get the quotient and remainder, and both the digits will be separated. So we'll see the program step by step. Move SI, 500. First, we have initialized SI register, this is source index register, to location 500. Then move AL, square brackets SI. Again, SI is pointing to a location 500, or it is the offset for the location where my input is present, which I assumed it to be here FF. Then move AH, 00. So I have cleared the upper part of my accumulator. Now it is 00. Then move CL, 64. 64H, it is equivalent to 100 in decimal. So we have just taken it in register CL. Now what I want to perform? I want to divide the content, divide my input 00 FF by 64. So I just want to divide 00 FF divided by 64. For your better understanding, I can say that FF is actually 255 and I am dividing it by 100. So if you will divide it, you will get 2 as quotient and 55 as remainder. So we have just divided the numbers. So we assume like we have divided FF by 64. So we'll be getting 2 as the quotient value and 55 as the remainder. So now next we says that increment SI. So just increment the location and you'll get to the next location where you can display the one of your digit, that is 2. Then move AL comma square brackets SI. What you are having in AL, when you have divided the contents of AX by CL, so you are having a quotient and a remainder. So you are having in AL the quotient value that I need to display. So at one of the location it was FF. On the next location I'll get 02. Then it says transfer the contents from higher accumulator to the lower accumulator register. So from AH I have transferred 55 to AL. Now again I have cleared the contents of AH because divide instruction, it says that you have to divide the contents of 16-bit register with the 8-bit register. So I've just cleared that upper 8 bits. Then again now I have to perform the operation division by 0, that is 10 in decimal. So divide CL. Again it will perform the divide operation. So the contents of AX, they will be divided by CL. AX is having, if I say in decimal, it is 55 and you have to divide it by 10. So it will be 5, 50 and again 5 will be the remainder. So again we incremented SI. We incremented SI to go to the next location. Why we incremented? So that I can just display my next 2 values. Next is move AL square brackets comma AL. So now this time AL is having the quotient, that is 05. So at first location FF was present. At next location you have displayed 02. At next again I have displayed 05. It again says increment SI by 1. Again I have incremented SI and this time I have displayed the contents of AH, that is your remainder part. So again at next location it will be 0. So in SI it was pointing at offset 500. So at the consecutive locations I am getting my output like this. First is the input and next 3 locations they are containing my output. So in this way the hexadecimal number has been converted to a perfect BCD number. So you have just got the unpacked BCD numbers from a hexadecimal number. And last location is again, the last instruction is again the INT A5, that is your software interrupt. Like we used to use the RST5 in case of 8085. So these are the steps. First we have got FF, we have divided by 64, 2 as the quotient, 55 as remainder, then 55 we have divided by 0A, we have got 5 as quotient and 5 as remainder. Next example we took here is a hexadecimal to ASCII code conversion. So we have got an input in hexadecimal, I have to convert it to the ASCII code. So what logic we generally used it here is, let's say I've got a hexadecimal number and if you've got a hexadecimal number, it can be either in the range 0 to 9 or it can be A to F if I talk about a single digit hexadecimal number. So the concept says if you have got a hexadecimal number from 0 to 9, you must add 30. If you have got a hexadecimal number from range 0 to 9, then you must add 37. So for 0 to 9, you have to add 30. For 0 to F, you have to add 37 hexadecimal. Why we have to add this 0 to 30 to 39 is the ASCII range for the numbers 0 to 9. Then you have got from A to F, that is 41 onwards, you have got the ASCII codes for your alphabet. And in between, like your 4A, 4B, 3A, 3B, 3C till your 40. They are the ASCII values for the special characters. So first is, we start the program, move AL comma square bracket 1300. So 1300, we have directly mentioned the offset address here. So this is the example of direct addressing. So this 1300 is the offset address where my input is present. So from that location, we have just, from 1300, we have generated the physical address, 20-bit physical address, and the contents are moved to AL. And we have copied the same contents to AH also. I assume any number here, maybe 08. So we have make it like 08 and 08. Then move AL comma 0F. So like I have assumed here only a single bit. If I say if it is 88. So we are saying that if you have got the number as 88, I am interested only a single bit because I have to compare it whether it is 0 to 9 or A to F. So I'm just masking. I'm again perform the masking bit. So you will just mask it with 0F. And you will get your answer as the single digit, that is 08. Now just compare this with 0A. Now you are comparing. Why I am performing comparison here? I want to know whether the number, whether my input, it lies in range 0 to 9 or it lies in range A to F. So I have compared the number and I said, compare AL, that is the input. Input here is 08 with 0A. Now check jump if bit. So if bit is set, or you can say jump if below. So if the number is less than, that is when you are comparing 08 and 0A. So it is like this. So the number is below than 0A. If the number is below than 0A, then what you should do, you should just jump to this location 01, 0D and you move on here and you should just add 30. So it was 8, I added 30, it becomes 38. And I'll next move 1301, AL. So we have displayed the result at this location. So for the 08, we have got 38 and we have displayed it. Next, we have exchanged the contents of AL and AH. So AH was already having 88. It has moved to AL now. And we said move CL 4 times. Just why? Again, I want it in the lower part. So I have initialized the counter to 04. Next is I am going to rotate the instruction. I want to rotate the contents of accumulate. I have got 88. So I'll just rotate it. And you again, because I have taken both the digits same. If I have taken it like 84, it becomes 48 after 4 rotations. So again, I have got 88. So I again perform masking with F0, with 0F, sorry. And it again becomes 08. Now again we'll perform the same operation. Again, I'll compare the number. I'll again compare the number whether it is less than 0A, that is whether it is in range 0 to 9 or A to F. So I've again compared the number with 0A and again said jump if below. Again in my case the number is 08. So 08 is less than 0A. So I have to jump at this location and I have to add 30. I've added 30 and I have displayed the result. The last is 98. Again I take another example. If suppose I have got a input maybe 3A. So what will happen? If you have got an input like 3A, so first you will just perform the masking on this. You will get it maybe 0A. If you have got it 0A, you will add 37 and you will got the answer as 41H, which you will display. So this is one of the answer for 41H. Next again I have loaded 3A. I just perform 4 rotations. It becomes A3. Perform masking 0F. Becomes 03. Now the number is in range 0 to 30. So I should add 30. 0 to 9. Then I should add 30. It becomes 33. So this is the second. So I've got 2 ASCII values, that is 41H and 33, which I must display. So it works in this manner. Next is if I want to perform the vice versa. I've got a ASCII number and I want to convert it to a hexadecimal number. So that means this time I need to perform the reverse operation. Like in the previous program, I have just added 30 and 37. This time I need to subtract the contents. So how can I perform this? So this time I have got the input which is above 30. So if you have got an input above 30 and so you can compare your numbers. If the number is less than 41, you need to subtract 30. Otherwise you need to subtract 37. So again you need to perform, this is the program I have taken here for a single bit number, assuming that I have got a single digit. So move AL, 1300. So this says that again 1300 is the immediate, it is the address for the input data. So it is, this is the example of your direct memory addressing. So at this address I've got the input. First I assume this input to be 39 and I have just subtracted 30. So just subtract it without thinking anything, just subtract 30. So it becomes 09. Now compare this number with 0A. So I am comparing this with 0A, jump if below. Yes, the number is below than 0A. Yes, the number is smaller than 0A. So if the number is smaller than 0, then I need not to perform anything. I need to just jump to this location where I say, just display my sum. That is move AL. The contents of AL will be displayed to this location. Again, take another example. If suppose I have got the input as 42. This time I've got as 42. For example, input is again 42. First you will subtract 30. Then you will get some answer, maybe 12. Then you will perform it, will compare with 0A. If the number is not below, so this time the 12 is greater than 0A, then you need to subtract again 7. So you will again subtract 7 from it. whatever answer you will get, you will just display the answer to this location. So this was all about the programming concepts related to 8086. You can just refer to the following 8086 books like B.B. Halls and B.B. Bray. And if you've got any doubt, you can contact me. Thank you.